This video is about Chapter 3, and by the end of this video, you should be able to define categorical data and display categorical data using a frequency table, a bar chart, a pie chart, a segmented bar chart, and a few others. You should also be able to use the area principle to discuss good and bad graphs. First, let's discuss two types of data that we'll talk about. Okay? The first type is categorical data, and this is data that can be categorized. For example, candy colors, yes/no responses on a survey, and sometimes class status, freshman, sophomore, junior, senior, can be seen as categorical data. It fits nicely into categories. The second type of data is quantitative data, and this is data that can be measured with units. For example, GPA is measured using grade points. Time spent playing mobile games can be measured in hours, and height can be measured in inches or centimeters. Now, we will spend a significant chunk of our year talking about quantitative data, okay, and how to analyze things that use quantitative data. But today, we're going to talk mostly about categorical data. Okay, specifically, how do you graph and represent and display categorical data? Now, the three rules of data analysis are make a picture, make a picture, make a picture. It's important that you draw pictures as you are analyzing data because you can see things in the pictures that you may miss looking at just the numbers. So here are several ways to graph and display categorical data. The first is using a frequency table. You simply have the categories and the counts or the number that fall into each of those categories. Okay. The second is a relative frequency table. Okay. And whenever you see the word relative, think about percents. Okay. So the relative frequency table has the same categories, but then the percent of the total that are in those categories. Okay, the next type is a bar chart. I'm sure you've seen and used bar charts in the past, but bar charts are one way of displaying categorical data. It's very important that you notice that there are gaps in between the bars. Okay, and that's because they don't have to be next to each other. There are different categories, and it's not necessarily one after the other, that there is a gap because they're separate, discrete categories. Okay, that's different from a histogram, which is a way of displaying quantitative data that we'll talk about in the future, okay, a bar chart. The fourth way is by using a relative frequency bar chart. Okay, remember relative means percent, and so it's just like a bar chart, but instead of counts or frequency, we have the percentages as the y variable. Again, you have gaps in between the bars because it is a bar chart. All right, pie charts. Pie charts are when they're graphed on a circle, on a pie. Now, pie charts should only be used when comparing parts of a whole. Okay, sometimes it's used when not comparing parts of the whole, and there can be problems with that graph. When I took stats in college, one of my professors was a retired statistician, and he said that in the business world, in the corporate world, pie charts are used far more frequently than they should be because it doesn't always fit this comparing parts of the whole requirement. So just be aware of that, that pie charts should only be used when comparing parts of a whole. The next type of display is a contingency table, where you're comparing two categorical variables. So here's some Titanic data, and we're comparing those that were alive and dead compared with their class, first class, second class, third class, and crew. Okay. Now you can very easily see that there were, for example, 118 second class passengers that lived and 167 second class passengers who died. Okay. Now, on the ends, we have what's called the marginal distribution. It's on the margins, like the margins of a paper. Okay, they're on the ends. Now, right here you can see the distribution of those who lived and died out of the total, and the bottom marginal distribution compares the class, first class, second class, third class, and crew out of the total. Okay, so you can still see, that those variables alone or compared in the middle of the contingency table. Now, there are several ways to look at conditional distributions, conditional based on some requirement. Okay, so this top contingency table is looking at a percent of the total. So of the total people on the Titanic, only 5.4% of them were second class passengers who lived, and only 7.6% were second class passengers who died. Okay, this would be very useful if you're trying to compare, different, standings based on living or dying. Okay, the bottom graph is looking at comparing of those who lived and those who died, looking at that variable specifically. Okay, so of those who lived, 28.6% of them were first class, and 29.8% were crew, for example. Okay, and of those who died, 8.2% were in first class, and 45.2% were crew. So you can compare looking at that variable. And you can also look at it comparing it based on class if you wanted to. Okay, another way of comparing distributions is by using a side-by-side bar chart. So here I have bars for first, second, third class, and crew, but I've lined up the percentage who lived and percentage who died so that I can easily compare those for each of the class, ticket class. The next way to compare distributions is by looking at a segmented bar chart. Okay, here I have one bar for those who lived and one bar for those who died, and I have it segmented, so broken up into pieces based on the relative percentages. Okay, again, I can compare, those who lived and those who died, the percentages, very easily because they're next to each other and that they're color-coded. Okay, so I can see very easily that there was a higher percent of people who lived in first class than who died in first class. Okay, now be aware that this has to do with percents, not counts, and so from just a segmented bar chart, we would know nothing about the counts. There could have been, for example, more people who died on second class than who lived on second class based on the numbers, but not based on the percents. Okay, the last principle to talk about is the area principle. The area occupied by a part of the graph should correspond to the magnitude of the value it represents. Okay, so all the graphs on this page have some problems with them. Okay, some more than others. Okay, so this graph is displaying the frequency of passengers in first, second, third class, and crew. Okay, the problem with this is that it's being stretched horizontally and vertically. Okay, so the scale is here on the horizontal axis, and I'll take, for example, first class has about 300 people, and third class has about 600 people. Okay, now that is double, so third class is roughly double first class. Okay, but because there's a picture there, and it's being stretched horizontally and vertically, that the picture of the ship is, for third class, is actually 4 times bigger than first class, not twice as big, it's 4 times bigger. And so it's kind of harder to tell from this picture, how many people were on third class as compared with first class, because the picture is so much bigger for third class. Okay, a similar thing happens with this pie chart down here. It's turned on its side, and you can see kind of the height of that pie chart, but that adds extra area that shouldn't be there. Okay, and the angle it's turned at can also be a problem. Okay, we know that crew is the largest ticket class. Okay, but based on this picture, it doesn't look like it's by far the biggest. It looks comparable to third class, and even in some ways comparable to second class, which is the smallest class. Okay, so by turning it on its side, it does distort or skew your perception of which class had the most and least, and your ability to compare the different ticket classes. Okay, the last one that you'll see frequently are bar charts that are drawn like this, where there's a height and a side. Okay, even though it looks cooler, there is some extra area added to it because of its three-dimensional nature that it's being graphed as. Okay, so just be aware of the area principle. Graphs that maybe not look as cool may just simply be the best ones to use because it follows the area principle. So this video was about displaying and describing categorical data. You should be able to define categorical data. You should be able to display categorical data using a frequency table, a bar chart, a pie chart, a segmented bar chart, a contingency table, and also be able to use the area principle to discuss good and bad graphs. Thank you for watching.